For this episode, let's talk a little bit about the software that runs the Apple II Pi environment. Here we see our Raspberry Pi OS desktop with our terminal window open. And here we are going to show the Linux side of the protocol handler so that you can see what goes on behind the scenes. I'm doing a kind of a close-up screencast so you can kind of follow along and see what's transpiring. And I can't really do much of a screen capture on this poor little Pi. So this will be our interactive software discovery session. First, let's look at the main brains of the system under Linux. This is our Apple II Pi daemon that is started when Linux boots with a service started by systemd, and the A2 Pi daemon is responsible for marshaling all of the connections from various Linux programs and drivers down to the serial interface that we talked about in the previous section into the Apple II client program. So A2PID starts early on. It will create the connection to the Apple II and then provide an interface to all of the drivers and programs running under Linux. In fact, I'm currently running the joystick mouse driver, and you can see how our mouse moves as I move the joystick. That driver runs as this driver. Now I just loaded this by hand. However, I can go into Linux and include that as a startup driver or run it just when I feel the need to. The other drivers for, say, the keyboard and the Apple II mouse are always available on the Apple II client without having to load any specific drivers. But some of the ones that may not make sense to include by default are provided as additional drivers that communicate through the A2 Pi daemon. Now it's interesting, they actually load a little program that runs on the Apple II, and those also communicate back to the Linux side of things through a corollary program that runs on the Apple II. We can go look at that real quick by changing our input to look directly at our Apple II on our AV input. And we see here our Apple II is running a specialized client and displays the message that the keyboard is routed to Linux. So whatever we type on our keyboard doesn't show up under our Apple directly here, but is instead treated as an additional input device on Linux. But we also see a message about the Pi drives that are available under slot 7 disk 1 and slot 7 disk 2. This is a device driver that works again in conjunction with the Apple II Pi daemon to provide ProDOS compatible disk volumes to the Apple II. To see these, what we can do with our Apple II client is actually exit out. We use open Apple, closed Apple, and delete. Now this kind of exits out of our Apple II client so that we can use our Apple II just as an Apple II. If we exit back to ProDOS, we can see that we have a couple drives available to us. Here's one called Utils, and here is the A2Pi client disk image. This is actually one being provided by the Pi drive, our RAM drive. And this is the actual client running on the floppy disk that I used to boot this Apple IIe with. We can return to our Apple II Pi client by just rerunning BASIC, and this will load the startup disk, and then we get our messages again. Now our Pi drives have already been connected, so we didn't try to connect them again. Let's go back to Linux. Let's look at what the drives look like from the Linux side. On the Linux side, we take advantage of the Fuse environment, the user file system drivers, to again communicate through the A2Pi daemon to get access to the storage devices on our Apple II. And as we booted this, we ran a program called A2Mount to mount our Apple II files under a ProDOS directory. Here we see, just as we did from the Apple II, our two A2Pi images, one actually on the actual floppy, one being supplied by the Pi drive, our RAM drive, and our Utils volume. And what makes this a little confusing is that this is a bit recursive. Our Utils and A2Pi volumes are actually being supplied by Linux to the Apple II. When we go to mount the Apple II drives, it will go ahead and mount those images being supplied by the Apple II Pi daemon. Now it's a little confusing, but those actual disk images live right there. So we see actually a previous version of the A2Pi client, the current version of the A2Pi client, and the Utils disk image volume. Those are being currently supplied to the Apple II as some virtual Pi drives, which we can actually view through our mounted drives, if I spell it right. And those are the actual files inside of this Utils drive image as seen from the Linux Fuse driver mounting the Apple II volumes. That's probably a little confusing, but it's a pretty cool way of having Apple II drive images show up under Linux as just a regular file system. So once again, the Apple II Pi daemon marshals all these requests from the different drivers and programs to the Apple II It was called in a software synchronous fashion. So on the Apple II side, it doesn't require interrupts to run, and it can run basically flat out. The serial interface runs at 115 kilobaud, so it's as fast as the super serial chip and the UART on the Raspberry Pi can go. That's their max ratings. So that ends up being about 10 kilobytes per second data transfer rate, which isn't too bad. It's nothing like a modern CFFA or other storage options available on the Apple II. But it's not a terrible implementation. It certainly provides enough bandwidth for input devices like the keyboard and mouse and joystick, and provides an adequate interface for the block devices like our floppy disks and RAM disks and other storage devices on our Apple II. So again, one of the programs we've demonstrated earlier was one called A2Term. This is a program that will allow an AppleSoft session to run under Linux. So we are now currently connected, again, back to our Apple II in an AppleSoft environment. There's no programs loaded, but we can type one in. We can run it, and we can list it. So we can see that this is a pretty interesting way to interact with your Apple II. When I go back to our Apple II video, you will see that we are interacting with our Apple II just as we normally would, except now everything we type goes to Linux and then back to the Apple to be used as keyboard input. And the way this works is Steve Wozniak, in his infinite wisdom, provided some hooks for reading keys and printing characters. And what the Apple II Pi client running on the Apple II does is it connects to these hooks and interjects itself so it can pull information off of the keyboard and mouse and send it to the screen or redirect it to Linux. And in this case, the A2Term program that we're running on Linux instructs the Apple II client to reflect what's being entered in on the keyboard right back to AppleSoft. Again, this kind of makes your a recursive kind of loop to send things around. But again, let me just show you. I can type, I can run our program. It all looks just like AppleSoft. Now these hooks will get reset if we should exit out and return to ProDOS. So as long as we stay in our AppleSoft session, everything will behave. There are times when you may want to return to just an Apple-only environment, but for now we're just going to show off what we can do with this A2Term program and AppleSoft. But it turns out it's not just AppleSoft. We can go into the 6502 monitor and interact with the machine code that's there. Again, the hooks are still in place, so whatever we type gets reflected back to Linux. So if you look at the screen now, and we go back to our Linux A2Term window, you will see that everything that was typed in and printed out exists in this window as well. We'll return to AppleSoft, and what we can do is bring up another terminal window. One thing that the A2 term allows us to do is to redirect input into it. So if we go to the share directory for A2Pi, we have something called exec file that's included there. If we look at that, we'll see it's actually an AppleSoft program. So what we're going to do is we're going to run an A2 term, but we're going to take the input from our exec file. When we first played around with our Apple IIs, you may have used the DOS method of using exec files, and this is very, very similar. This just takes a text file and pretends like you're typing it in. So this window will take the contents of the exec file and poke it into A2 term, which again connects to our AppleSoft session on this window, and we will watch as that file gets typed into AppleSoft through the exec file, and then it runs it. So there you can see how we can edit and run AppleSoft programs being edited in Linux and then copied directly to AppleSoft for testing and running, and we can save it then to a disk file if we so desire. So this is just another benefit of being able to use Linux as our development environment, yet then be able to actually run it on our Apple II hardware for testing and saving if we so choose. Again, everything gets marshaled through the Apple IIPi daemon under Linux and the Apple IIPi client running on the Apple II, all in a software synchronous environment. Now, it is possible to lock up our interaction if we were to go into AppleSoft. Say we just make a program that just loops on itself. If it doesn't print anything out or request input, then we actually lose our interactivity. So right now we can see that my mouse moves around. Let's make a program that doesn't do anything, it just loops. 10, go to 10. What this is going to have the effect of doing is locking our Apple II client out of its interactivity with Linux. However, there's an easy way out. It's running AppleSoft, so we can again just use Control-C as we would under AppleSoft to break out of that program and return control. So let's give that a run. While it's doing that, we have no interactivity. So my joystick is gone. I can't type anything on the keyboard and have it respond. If I use Control-C to break out of our AppleSoft, then lo and behold, our mouse works again, or joystick mouse. Our keyboard is back. So that's the one limitation of running without interrupts in a software synchronous fashion, is that a program running on the Apple II that doesn't request input or print to the screen can kind of lock us out of our Linux input-output session. Now, because our Apple II Pi client on the Apple II is just a program, all we have to do, should that happen and we can't get out of it, is just hit reset. And that will reconnect the vectors, the I/O vectors, and return our functionality. Should it get even worse than that, should memory get overrun and we lose our actual programs, we can reset and reboot the Apple II independent of our Linux operating system running on the Pi, so that it would reload the Apple II Pi client and reconnect, and then we would be back where we started. So having an actual computer as the Apple II running input and output has a lot of really interesting ramifications. Imagine being able to run programs on your USB keyboard, for instance. It's that kind of thing, and normally you would never even consider that, but in this case it is entirely possible and actually kind of fun. So we can take this one step further. Under our share drive, we have a couple other little examples of how we can interact with our Apple. It doesn't just have to be AppleSoft. We can use machine code that we download to the Apple II and run that as well. And if any of you have ever seen my Apple I birthday tribute program I wrote 100 years ago, I just made a version that runs on the Apple II, and there are two ways to do this. There is a binary that was assembled into just a raw binary file, and there is a monitor version which just sends the monitor commands. So again, it looks like you were just typing it in, but let's look at these real quick. The monitor file looks just like stuff you would type in into the monitor as hex code. And you can see it's a start address of 2000, and then following just the data that makes up the actual slideshow. If we were to look at the binary file, which we can do with hexdump, again, it's just a bunch of numbers, but that just shows us the actual raw data. Now, to load this into our Apple II and run it, all we have to do is use some of the included utilities to load and run binary files. And what we're going to do now is actually use bload, and we're going to, because I don't want to run it right off the bat, I want to show you something. We're going to bload the slideshow, the bin, and we provided an address. We're in Linux, so we're going to use the Unix style of hexadecimal. We have loaded our slideshow into our Apple II at address 2000. We haven't run it yet. I just loaded it. But let's go over here to our AppleSoft environment. I want to go to our 6502 monitor. Let's see what we find there. We now find that program loaded right where I wanted it to go, ready to run. So let's run it. 2000 go. Now you'll notice that it's doubled up. Our slideshow wants to run as 40 columns. So here's what I'm going to do. I stopped it with the escape key. I'm going to take our terminal window here, and I'm going to shrink it down to 40 by 24. I'm going to run that again. Oops. And now we see the slideshow running in 40 columns as it was designed for on the Apple I, but running on an Apple II, putting its output into a Linux terminal window. So that's a pretty interesting way to do some Apple II development, I think. Again, you can do all of your programming on the Apple II. And we're going to escape out of this with the escape key. Our interactivity comes back because now we're using our I/O hooks. I included a few tools in the latest SD card image for the Raspberry Pi. We have a nice simple little assembler called Acme, and Acme is what a lot of projects use, including Lawless Legends, for its assembler. Plasma uses it as a back-end assembler as well. Nice little assembler, also supports the 65816, and it is easy to just build a single binary that you can then load and run with the bload and brun commands that are included in the Apple II Pi distribution. Also included, CC65. This is the C compiler for the Apple II, and you can use this to build and write programs that, again, you can run directly on the Apple II with brun and bload. You can also run them under the emulator that's included, GSPort emulator, if you want an environment that has a debugger built in, has 6518 support. So you have a plethora of options for developing under the Apple II with the Apple II Pi environment, all using your Apple II hardware as both Linux and Apple II aware device. So there are a number of other little programs that are available. Apple II Pi manual is included here on the desktop. You'll see it. It wants to normally open with the web browser, but we'll use the PDF viewer to open up our user manual. And this will have a somewhat brief but more or less thorough description of a lot of the utilities that are available under the Apple II Pi environment. The table of contents, when we get to that, are fully linked, and you can see what's all included. Here's our input using the joystick mouse, also using a KoalaPad style device as your mouse. So that's kind of a neat way to interact again with the Linux desktop, is through your KoalaPad. We talk about the Fuse environment for mounting the Apple II devices under Linux. We have a description of our development tools. The A2Mon, the A2Term, the bload, the brun. We also have some utilities for creating floppy disk images. These are not that sophisticated. They're really kind of cheesy, but they will just make a image copy of whatever's in your slot 6 disk 1 floppy disk. It only worked with 140K floppies, but this was one of the very first utilities I wrote, and serves its purpose for making cheap, quick, and dirty disk images. There are some additional versions that will do nib files and whatnot, but these are just a very, very simple little utilities. We have some of our supplemental files which we can use for testing out what I just showed you, the slideshow, the exec file. And should you want to write your own programs under Linux that interact with the Apple II directly through the A2Py protocol, this will talk about the A2lib file that you can include and write your own interactive programs that communicate between Linux and the Apple II. You will find all the software for the Apple IIe environment on GitHub. I'll put a link in the description of the video, and with that you can download, compile, build your own. If you want to run the Apple IIe Linux tools and utilities on a different version of Linux, for instance, under an Intel 64-bit version of Ubuntu, you will have to compile your own version, and you can do that by getting the source code and compiling it yourself. I've used it under 32-bit Intel, 64-bit Intel, 32-bit ARM, 64-bit ARM, and 32-bit PowerPC, so I'm pretty confident it is rather portable and able to work under just about any Linux environment you'll come across. Other than that, that is the quick, brief, somewhat confusing introduction to the Apple IIe software environment and kind of how it works. Hope you liked it. Thanks for watching.